Good day, students. Welcome to mathcodeserve.com. In this clip, we're going to be going over problems 21 to 25 of the CBIS Mathematics Practice Test, focusing on computation and problem solving. If you have any questions during the course of this presentation, feel free to ask your questions in the comment section below, and we'll be glad to support you. All right, let's take a look at question 21. It reads, a sporting goods store is offering a 10% discount on online skates that normally cost $110.99. How much will the inline skate cost with a discount not including tax? Okay, so let's start by writing down the formula for computing the discounted price after applying a percentage discount. So discounted price can be determined by calculating 1 minus the percent discount over 100 to convert it into decimal form or fraction form, multiplied by the original price. Okay, so this is the formula we're going to be using. So we can see that to calculate a discounted price, you need two variables, namely the percent discount and the original price. And those two values are provided for us in this problem, okay? So let's write down what they are. Percent discount is 10%, and the original price before the discount, the original price is $110.99. Okay, so what are we looking for? We're looking for the discounted price. All right, so let's write that down. Discounted price is basically 1 minus the percent discount using this formula, 10 divided by 100. This converts the percentage into fraction format, times the original price, 110.99. To facilitate this problem solving process, we can convert this fraction into decimal. So how do you convert 10 over 100 into decimal? Well, you just move the 10, the decimal point in the numerator, the number of times that requires to convert the denominator into 1. Okay, so we have a decimal point here, a decimal point here. We want the denominator to be 1, so we're going to move the decimal point to the right, to the left, 1, 2. So what does that mean? Move the numerator decimal point an equivalent number of times. 1, 2, bam. So 10 over 100 in decimal form is 0.1. Okay, so let me just finish this up right here. So it's 0.1 over 1, which is just 0.1. So we are computing 1 minus 0.1. 0.1 is 10% in decimal format, times 110.99. Okay, and now we have 1 minus 0.1 is 0.9. Multiply that by 110.99. Okay, so let's go ahead and multiply it out here. Remember, in this test, we're not allowed to use a calculator, so we have to do all our computations by hand. Okay, so let's multiply this 5-digit number by a 1-digit decimal right there. So we have 9 times 9 is 81, 1 carry 8. 9 times 9 is 81, 81 plus 1 is 89, so put a 9. Forget about the decimal, okay? Carry 8. 9 times 0 is 0, plus 8 is 8. 9 times 1 is 9, 9 times 1 is 9. So the question now is, where do we position the decimal point? Since we have 3 digits, 1, 2, 3 to the right of the decimal, that means we're going to put 3 digits to the right of the decimal. So our decimal point is going to go right here. We know that currency values are up to 2 decimal places, so this result is going to be, we have to round it to the second decimal or the 100th place, so it's going to be 99.89. So the cost after the 10% discount is $99.89. Your answer is option letter A. Okay, let's take a look at question 22. It says, at the beginning of a class period, half of the students in the class go to the library. Later in the period, half of the remaining students go to the computer lab. If there are 8 students remaining in the class, how many students were originally in the class? So our unknown is the amount of students that were originally in the class. So let's declare our variable. Let x be the number of students originally in the class. Okay. Now, two events happen here. Okay, we had students departing at the beginning, and then later on, more students departed. So let's break it down. Let's start with what happened at the beginning. At the beginning, 1/2 leave. Okay, so if 1/2 leave at the beginning, how much do we have left? So number left is equal to the original number of students, because none have left yet, minus 1/2 of the original. Okay, so number left is going to be, but now let's make use of our variable x minus 1/2 x. So what is x minus 1/2 x? Imagine that there's a coefficient here which is 1, so we are basically subtracting 1/2 from 1. What is 1 minus 1/2? If you subtract half a dollar, 50 cents from a dollar, you end up with half a dollar. Okay, so 1 minus 1/2 is 1/2 x. So this is how much number we have left at the beginning of the class. Okay, all right. Now after that, later in the period, later in period, 1/2 of the amount left leave. Okay, so 1/2 of the amount that left leave. So now how many students are going to be left after 1/2 of the amount of students leave? So the number left after the second departure is going to be the number left. Let me put some indices here so we don't get it confused. So let's call it 1. Put index 1 for the first, the amount of students left after the first departure, and then let's put 2 for the number of students left after the second departure, okay? So the number of students left after the second departure is the number of students left after the first departure minus 1/2 of the number of students left after the first departure, okay? So let's see what we have. The number of students left after the second departure is going to be the number of students left after the first departure. We calculated that to be 1/2 of x, half of the original, minus 1/2 of the number of students left after the first departure, another 1/2 x. Remember, of means multiply, okay? So let's go ahead and calculate the result of this. We have 1/2 x minus half of a half. You multiply numerator and denominator together, you get 1/4 x. This is the number left after the second departure. So to compute this difference, you find the LCD, multiply this by 2 top and bottom so that the denominators are identical. Okay, so we have 2 over 4x minus 1/4 x minus 1/4 x. If you subtract, you end up with 1 over 4x now. After the second departure, the number of students left is 1/4 x. Okay, but what does the problem tell us? The problem tells us that 8 students are remaining after the beginning departure and the second departure later in the period. Okay, so guess what? We can take this variable here and replace it with 8. 8 is the number of students left after the second departure. That's equal to 1/4 x. To get x isolated, multiply both sides by 4. And then you have x equals 32. This is the number of students that were originally present in the class. Answer is option letter B. All right, let's take a look at number 23. It says Peter works 38 hours per week and earns $7.25 per hour. His employer gives him a raise that increases his weekly gross pay to $307.80. What is the increase in Peter's weekly gross pay? Okay, so let's write down the formula real quick. So increase is basically the increase is given by final amount, final earnings in this case minus the original earnings. Okay. So let's start with what the original weekly earning is. So original weekly earning is going to be number of hours worked, 38 times the hourly rate, $7.25. Okay, so we've got to multiply the amount of hours he works times his rate per hour. Okay, let's calculate that on the side here. 7. Now, this has 2 decimal places, this has none. So I'm going to put the number with more decimal places on top. Remember, we can't use calculators here, so we need to know all these little tricks to help us to multiply correctly. Okay, 8 times 5, 40, 0 carry 4. 8 times 2 is 16. Plus 4, that's 20, 0 carry 2. 8 times 7 is 56, plus 2, that's 58. All right, 3 times 5 is 15, 5 carry 1. 3 times 2, 6, 7. 3 times 7 is 21. And then just add it downwards. You have 0, 5, 8 plus 7 is 15, carry 1. 2 plus 5 is 7. Okay, now, where do we place our decimal point? We have 2 digits to the right of the decimal, so we're going to position our decimal point right there. So that's his original earnings, working at this rate for 38 hours. So the product is 275.5. So does that mean our answer is D? The answer is no. We were asked to find the increase, okay? We know what the original is. So what is the final earning after the increase? His final weekly earning is given by this amount right here, $307.80. So we're now going to use our increase formula to determine how much increase he got, okay? So the increase is basically 307.8 minus 275.5. All right. Okay, so to make our subtraction easier, you want to orient your digits vertically and align your decimal points. Okay, and then subtract. 853,752. Well, this can't go, so borrow 1. 10 minus 7 is 3. It's left with 2 is 0. All right, so the increase is $32.30. Option letter A. All right, let's take a look at question 24. It says, use the diagram below to answer the question that follows. It reads, Aguilar Manufacturing Company packages a product for shipping by wrapping tape around the package as shown in the diagram to the right. An additional 10% length of tape per package is needed for the overlap. Okay. Question, what is the total length of tape needed per package? So to get started, let's write down the formula we're going to be using here. We're looking at a 10% addition or increase, okay? So our formula, we're going to increase the entire length to wrap this package by 10%. So it's going to be increase in length equals the percentage increase in decimal form, which is 1 plus the percentage increase over 100 Okay, we're going to multiply that by the original length. Original length. Okay, all right, now let's see. So what we need to do is we need to find the original length. So the original length is what? I don't know what the original length is. So we're going to use this shape to the right, to the left, to figure out what the original length is. So we have tapes going left, right, and forward, back. So this tape right here goes around the box. We know the box has, we have the top, bottom, the front, and the back with the tapes that are going back and forth. So we're gonna have, let's see, we have, the height is 5, right? So we have 5 here, and we have 10 on the top. So 5, 10. Okay, front and top. What else do we have? We have back and bottom, right? So at the back over there, we have another 5, and at the bottom, we have 10. Okay, so we do top, bottom, front, back for the length of the first tape. Same goes here. Front, top, I'm sorry, going too fast. Front and then the top is 5, 10. Okay, and then the back is 5, and then the bottom is 10. So that's for the first tapes that are going back and forth in this direction, left, right. Okay, so let's go ahead and write out what they are. So the length of this first tape right here is going to be double the height. This is the right side and then the left side. So double that is 5 units long because you have a 5 here. Plus the top and bottom. The top is 10, the bottom is 10. You double that. Bam. That's how much tape is used, the length of the tape for this section. Okay. So if you add it up, we have 10 plus 20, which is 30. Okay, so the first tape is 30 units long. Guess what? This tape is exactly the same length as this, so that's going to be 30 inches long also. Now, how about a tape that runs from front to back? This one right here. How much tape is used there? So going from on the top, front to back is 15. That's from here all the way to there. And then on the front, from top to the bottom is 5. We also have tape running down the bottom. That one is 15, and then we have a tape running at the back from top to bottom, that's 5. It's just like what we did over here, but we're just switching the orientation, okay? So how long is this tape running front and back? This tape is going to be, you double the front because you have front and back, plus you double the top, which is 15 because you have top and bottom. So that gives us 10 plus 2 times 15 is 30, which is 40. Okay, so let's plug it in. The original length is going to be the combined length of tape 1, tape 2, and tape 3. Okay, so it's going to be 30 for tape 1, 30 for tape 2, plus 40 for tape 3, which is 60 plus 40, 100 inches. Now, what are we going to do next? We're now going to apply our increase in length formula to determine what the final length is going to be. Okay, so in the increased length is going to be 1 plus the percent increase, which is 10 divided by 100. To convert this to fractional decimal form, times the original length, which is 100. Okay, now if you convert 10 over 100 to decimal form, just move the decimal point to the left once, that's 0.1 times 100. All right, and then let's combine these two. We have 1.1 times 100. Okay, so what is 100 times 1.1? 1 times 0, 0, 0, 1. Same thing, 1, 0, 0. So we have 1, 1, 0, 0, 1 decimal place. The answer is 110 inches. Answer is option letter E. All right, let's take a look at question 25, the last one in this review installment. It says Arturo is driving at a speed of 50 miles per hour. At 2 o'clock, he sees the following sign. This is how far it is to get to these destinations. So it says Arturo continues at the same speed at 2:30. How far from Canaan will he be? Okay, so we know that. Let's draw a timeline here. All right, so this is the timeline right here. At 2 o'clock, that's when he sees the sign. And at this point in time where he sees the sign, we're talking about Canaan here, he is 62 miles from Canaan, okay? So from here to here, the entire length is 62 miles. And then he travels for 30 minutes or half an hour to somewhere here. So this is at 2:30. Okay, so the question is, how far from Canaan will Arturo be? So from here to from here 2:30 to the end. Oh, I didn't put Canaan, so this is Canaan right here. So this is what we're looking for. How long is that? So in order to compute how far Arturo is from Canaan, we need to determine the distance that he traveled in half an hour. Okay, so how far did he travel in this 30 minutes or half hour time span? Let's make it red. So we need to find this, and then as soon as we find what this distance D is, we subtract D from 62 and we get what's left. All right. Okay, so this is the formula we're going to use to compute the distance. Formula, this is the distance is equal to rate or speed times time. This is known as the DIRT formula. So if you forget this formula, just think DIRT and you're good to go. All right, DIRT formula. In this problem, we're trying to find big D, okay? So big D is an unknown. The rate is how fast is he traveling? He's traveling at 50 miles per hour. And then from 2 to 2:30, we're talking about hours here. Time is half an hour, okay? 30 minutes. Our units have to be consistent, which is equal to half an hour, okay? So the distance is going to be the rate, which is 50 times the time, which is 1/2, not 30, okay? Gotta be careful. So 50 times 1/2 is 50 over 2, which is, let's try that again. 50 over 2, which is 25 miles. All right, so is our answer option letter C? The answer is no. Remember, we just found this distance right here. This is how far he traveled in 30 minutes. The question asked, how far is he from Canaan? Okay, so we have to compute the difference. So distance from Canaan, after traveling 25 miles, know that he's 62 miles away, you have 62 minus 25, and if you borrow 1, 12 minus 5 is 7, and then 5 minus 2 is 3. It's 37 miles. So that's how far he is from Canaan after traveling 50 miles per hour for half an hour. Answer is option letter E. Thank you so much for taking the time to watch this presentation. We really appreciate it. If you found the contents of this tutorial beneficial for your preparation for the upcoming CBS test, to give us a thumbs up. Your positive feedback is very important to us. If you have any questions or comments as indicated earlier, just place your questions in the comment section below and we'll be glad to support you. More clips can be found on mathgoodserved.com, and please do not forget to subscribe for the remainder of this review series. Thanks again for watching and have a wonderful day. Goodbye.